It's a great honor to be here in the University of Setif to give this presentation. So, first of all, I would like to extend my big thanks to the organizing committee. Organizing a conference is not something easy, and they have to put a lot of effort. So, Dr. Toomey, thank you for inviting me and for providing me this opportunity to give you a talk. I decided to talk about something that is very close to my heart, which is how do we talk a lot about research areas are a bit like fashion. You know, people get excited about something and then they get excited about something else and then they get excited. So a few years ago, everybody was excited about data science. Now everybody is excited about AI. And sometimes people get a bit confused. You know, what's the connection between data science and AI, and what does that mean? Does it mean I have to forget what I've done and do something new? So I wanted to talk about, you know, what does that mean, the AI revolution? What does that mean for people who have invested a lot of time working in the area of data science? What's the different connection? Before that, I come from the University of New South Wales in Australia, which looks very far, but you'd be surprised that there's many very big names, Algerian names, who are there. Professor Bougataya is a big world leader, and I believe he came here a few months ago, and he's a fellow of the IEEE. Professor Boualem Ben Atallah, he's now in Ireland. Professor Zahir Tari. So you actually have a lot of big names in computing in Australia, and I think I heard what people were saying about IEEE, and I would like to reinforce the message. It's good to be involved in IEEE, to be part of the world community, to contribute, and we are here. All the academics are here to help you as well. Don't hesitate to ask. So our university, I think in the world rankings, changes between 44, 70. So it's a fairly good university. One thing that this university does, which is also connected to the topic of my talk, is it engages a lot with industry. And particularly, Sydney is the economic capital of Australia. So the finance business is the main industry. And I know this conference is mainly engineering and looking at engineering, but I also would like to focus on two things: how to do research that is relevant to industry, how to do research that involves business, because I always believe that these are the sort of area that bring a lot of advantages, particularly to a developing economy like Algeria. I love multidisciplinary work. So my background is computer science, software engineering. So I did a lot of software engineering. I actually graduated from Babazouar in 1986 as a software engineer. But I like to apply my skills to other areas. And I worked a lot with business, economics, and social sciences because I find that these people have lots of problems, a lot of very interesting problems to solve, particularly when it comes to areas like finance, commerce, business. And I would like to make a case, perhaps for some of you, to start getting engaged into this kind of application. And the other area is data science. So within data science, also, we're dealing with large amounts of data. And then there is the intersection between software engineering and data science, and the intersection between data science and business, and the intersection between... So maybe another piece of advice is many researchers, they feel hopeless, saying, oh, we're in a small universities, we don't have really a lot of facilities. How can we do research? It's impossible. So my advice is, true, if you stick to one area, it's very hard to do research. But if you start going into multidisciplinary area, you have more chances. Because if you look at the cross between two areas, there's so many problems that other people haven't looked at. So I always find that small universities, researchers maybe that are don't have big budgets, don't have a lot of resources, it's always good to go into multidisciplinary areas, because multidisciplinary areas, they are not looked by the big boys. The big boys like to do the big research, and you find some niche areas. So niche areas, areas that fall between the cracks, these are the sort of areas that are always very useful in the research. So that's my background, engaging between different people from different areas, engaging with people from industry, engaging with people from different countries. So I like to create connections. I like to create multidisciplinary projects. And in particular, I find that this is very useful when it comes to industry. Industry doesn't like one expert. They usually will involve multiple experts, and I will explain that in my talk. So that's regarding my background, and also I'm from the Setif area, so my family is from Elma, so I'm very proud to be here and contribute something to the land of my ancestors. So AI, everybody's talking about it. What is it? So I want to actually define what AI is, because there's also many, many different interpretations, many different understanding, and many people are confused. And then AI being done in research is very different from AI that industry wants. So what's the difference between the AI that industry wants and the AI that us as academics are doing? First, before we talk about artificial intelligence, what is intelligence? So it looks obvious, but we want to acquire and apply knowledge and skills to accomplish a process. So that's why we are intelligent. Then, what is knowledge? Knowledge requires language, memory, attention, and so on. So then, intelligence, a subset of intelligence is the analytical intelligence, because you use knowledge to do the analysis. But then, you use your skills. So the skills are based on observation, experience, practice, feedback, decision-making. Then that's a different type of intelligence, which is cognitive intelligence. How do you get that capability to acquire and apply the skills and knowledge? That's another type of intelligence. It's called generative intelligence. Then, when you look at the process, well, you have to have the different steps that you have to apply. And that's something we don't associate with intelligence, but that's important for intelligence, and it's a business process. So people are intelligent when they can think about a business process to follow. Having given the definition of intelligence, now we can define what is artificial intelligence. And because there's different types of intelligence, then there's different types of artificial intelligence. And I think that's something many people don't realize. I use AI and I just use a software and this is AI. That's not AI, because there's different types of intelligence, then there's different types of artificial intelligence. So if I go back to the definition of intelligence as being the capability to acquire knowledge and skills to achieve a process, and if you go to analytical AI, cognitive AI, generative AI, then these types of AIs are all subsets of the field of artificial intelligence. And they work in different ways, they have different techniques. And similarly, if you go to business process, you're talking about automation, augmentation, and improvement. So really, I find it very hard for when people say, I'm going to learn AI. It's a huge field, there's different types. So if you look at techniques, all these techniques can be considered AI. Of course, most people, when they say AI, they think machine learning, which is part of analytic AI. But for me, data mining, predictive analytics, regression, even the old statistics models, they are part of AI, because you're analyzing data. Fuzzy logic is AI. And then when you look at cognitive AI, natural language processing, cognitive computing, sentiment analysis, when you look at generative AI, which is what is being talked a lot these days, we're looking at text-to-image synthesis, how you can create text from various descriptions and so on. So this is just to show you that AI, I would not tell it's one thing, it's an umbrella. But that umbrella will cover many things that you already know. So as engineers, you all have been doing AI in one form or another for many, many years before AI became a fashion. Okay, so that's the first thing, is it's an umbrella term that covers many of the things that already existed. Now, if we look at how AI is done in research labs, a particular research group specializes in cognitive computing. They do modeling for cognitive computing. Another research group, they do research in machine learning. They do models in machine learning. A research group maybe specializes in statistics, fuzzy logic. They do fuzzy logic statistics. So really, academics are doing AI in different silos and not talking to each other. And maybe some people in business faculty are doing AI. Some people in engineering, some people in maths. So I don't know about this university, but in our university, people fight. They say, oh, you're not really the AI, we are the AI, and people are fighting. But according to my definition, yeah, they're all doing AI, so there's no point fighting. You're all doing different parts of AI in different ways. And everybody is building models. So I'm building a model to make a robot walk in a room. I'm building a model to detect images from radar. I'm doing a model to detect customers that will be buying certain products. So everybody is building model for something, but they are all isolated, doing it in isolation. And also, when I did computer science a long time ago, I was the only one who could program. So people say to me, so the model was engineers would do the modeling and the computer scientists would do the programming. But what's happening now is everybody can program. Engineers can program, business people can program, everybody can program. So everybody's saying, well, we don't need computing people because I can do it by myself. But what they forget is the programs that they build are not of high quality. They're just programs to test the model, to do some experiments, and to write the paper. As soon as the paper is written, the program is thrown, and that's it. I'll work on my next paper. So, but that's normal because I'm doing research. I'm just writing the code to prove my hypothesis. I'm not really doing anything that is important. And also, if you are in a research lab, data. You take data sets, you build your data set, it's nice, it's clean, you run your experiments, and you've got the results that you want. So AI in research labs is being done in a way that is a little bit, when it comes to the computing, the software, it's a bit archaic, but that's fine, that's how it's meant to be. However, when you go to industry, they want a system. They want a system to read data from IoT systems, maybe from applications, from social networks, from collaboration platform. And you gather all this data, you analyze it, and you use it for decision making because businesses, they have a purpose. They want to achieve a goal. So really, they're not looking at just one model. They're looking at the whole thing from one end to the other. So really, industry, what they want is the whole system. They don't want one model to predict something. So, conclusion, what is the difference between AI in academia? It's split into different groups that study different things. And of course, you can have people from machine learning doing their modeling, people from statistics. I would argue even people doing algorithms. It's a form of AI. For example, if you're old enough to remember expert systems, rule-based systems, Prolog, they are algorithms and they are still AI. data mining, people use language technologies and so on. But industry, they want solutions, so they want all these experts to work together to build a solution. Not only that, so they don't only require experts from engineering, like I guess majority of people here, but they also need experts from business, because the business, they understand what the system is supposed to do. So you can't build a solution if you don't know what it is. So if you say, I'm building a system to help traffic problems in Sétif, well, you have to talk to somebody who works with traffic problems and understands what the problem is. So you need domain experts. And it's interesting because when you think of AI, you don't think, I need to talk to a domain expert. But if you apply AI in industry, yes, because the purpose of the AI is to solve a problem. So without the domain expert to give you that information, you can't solve the problem. You need to talk to social scientists. So I know I did my studies in Algeria. So the best students, they do engineering, the worst, they do social science. Social science is not important, but it's actually very important because the systems we build have to be used by people, have to be used by society. And if you don't have any knowledge about social science, you can't. And that's why you get a lot of systems being built and not being used. Even people take a system maybe built for Europe, doesn't work here because the culture is different. So you need to involve these people and say, oh, if we build a system this way, would that work? And they say, no, actually, the way the Algerian mentality works, you have to do it a bit differently because otherwise they won't do it, So, and that's fine, that's everywhere. When you build solutions, you take into account social factors. You can't just build a solution from your head in a pure engineering way. You need people who understand the data, because you're gathering the data. You need the people who understand information management. So really, when I say AI in industry is multidisciplinary, I'm not talking just multidisciplinary from different areas in engineering. I'm also talking about other areas, from math, statistics, domain experts, people from information management, and so on. So really, you can't build a solution. I mean, that's my firm belief. If you work in industry, you build a solution, you can't do it on your own. It is a multidisciplinary effort that requires multiple experts. So you need multiple experts and a teamwork. And you can see now the difference with academia, because academia, if I'm a PhD, I work on my own, I can build a solution, I can do everything. But you do it in industry, you have to collaborate, you have to work with others. That's it, there is no other way. Let me give you some examples from industry. And these are the examples that I'm working on, or I'm working on recently. The first one is, our world is becoming more and more polluted, and environment is a big problem. So within the whole world, there is a new area called ESG, which is environmental, social, and governance. So with this area, we say, you need to collect data, and you need to be able to estimate how much you are contributing to the environment, because then you can set targets and say, maybe I'm polluting, I don't know, 1 million carbon, and next year I have to reduce it by 5%, and next year. So you have to set targets. So at the moment, these regulations, they are a bit loose, but in the future they will be very strict. So most companies will have to comply with the environment at different levels. So some people, for example, in the building industry, when you create your building, you have to use material that is environmentally safe. People in transport, they have to use fuel efficient. People in banks, even banks, you think banks, they don't have any connection with the environment. But banks, they make loans. You say, you can only lend money to companies that are, for example, environmentally friendly. So it's very important to gather data from different sources and be able to determine how much we are contributing to the environment. Now, ESG has 3 words: environment, social, and governance. Social is also part of it, meaning that not only you are contributing to the environment, but also to the society. So, for example, are you reducing inequality in a society? So if you reduce inequality, then that's a good thing to do. Governance is the way the companies are governed. For example, if a company allows people a voice from minorities, that's also being measured. So there is many, many regulations all around the world that are related to this area of ESG, and they require to collect massive amounts of data, and these massive amounts of data have to be analyzed, and when you analyze them, you have to determine whether you comply with the regulation or not. But you don't necessarily have to have regulations. It could be things that councils can impose. It could be something that customers, for example, you say, I'm not buying any product for a company that is polluting. Or, for example, some of the work we did, you buy financial products and people say, I don't want to buy from a company unless it's Islamic finance products, but how do you know it's Islamic finance? Because you have to analyze lots of different data. So this is, ESG is a big umbrella, and in it you find everything: finance, environment. And the reason I chose this is because you're all engineers. So you all work with sensors, you work with radar, you work with, so you work with instruments. And many of the instruments perhaps that people work with here can be a first step in collecting data, which needs to go up to the top to be analyzed for some kind of compliance with an ESG regulation. This is an example, and it's the monitoring of carbon emissions. So Europeans have more and more, not Europeans, the whole world, there's something called the Paris Agreement, where all the companies have to reduce the Scope 1 emissions, means that the burning of fuel has to reduce. But that's easy because you measure how much fuel you burn. But you have something called indirect emissions, meaning that, for example, imagine the University of Sétif, we ask, say, how much does University of Sétif consumes carbon? And everybody's like, we don't, we're not a power plant. Says, yeah, you do, because people come to the university by cars, they burn fuel. Maybe your labs, you leave your machines open all night, you're burning electricity. So when it comes to indirect emissions, it's very hard. You have data problems, you have interpretation problems, you have many, many different problems when it comes to measure indirect emissions. And why did I give this example? Because it is an example where you need engineers to collect the data, but you need also the business people to analyze it, interpret it, and then maybe lawyers, because if you have regulations that you have to comply with, you have to create reports and stuff like that. So it's not a problem that one person can solve on their own. You really need this system. So give you an example. We worked on a project with buildings, and you have to look at CO2, you have to look at temperature, humidity, because some regulations say within the building you have to have a safe environment. So IoT sensors will get the data, and then you get external data from the weather, and then you have to collect the data, analyze it, to see whether the environment is good. So you can see different sources of data. Another case I chose deliberately very different from ESG, it's e-business systems. Well, e-business systems, we have trading partners, they communicate with each other, they exchange documents, they exchange, for example, I'm buying goods, I'm getting an order, and then I have to send a document. So there's a lot of exchanges of documents, and many regulations are saying we could not use paper, you have to use electronic data. for everything from banking, payments, supply chain, even government reporting. So for example, in Australia, in the old days, when you finish your tax, you fill a form. It doesn't exist anymore. Everything is electronic. And you make all your submissions online. So the world of business is now being changed online. And there's a very good reason for that. Government want to push all these exchanges to take place electronically to make sure that they reduce fraud, and companies also can reduce their costs. So in this case, it's very different. You can have different entities. So an example here is a supply chain where you have different processes from creating material, production, shipment, management, doing the inventory management and so on. But it's not important the detail. What's important is you have lots of data. Now, what is the difference here and the previous example is a lot of the data here is text. So you have text, you have various PDF documents, you have images, and this information contain, these documents contain information on how much you paid, how much tax you've paid, what products are being exchanged, what products are being traded, who is buying from who, how is the delivery going, and so on. And then outside of the business document, you have markets, financial markets, and other types of markets. You have tax and customs. You have. When I worked in finance, I was looking at data sources, and they say you need to look at financial market data and so on, and you need to look at the weather. And I was like, the weather? Why is the weather? For me, finance and weather is two different things. They say yes, because when the weather is bad, in South America, the price of the coffee goes up. So if the price of the coffee goes up, then the company that produces the coffee makes less money, for example. So actually, it's interesting to see that we think different domains are separate, but they are all connected. You can have a financial domain connected to agriculture, agriculture connected to the weather, and the data from one domain is used in another domain. And going back to my first statement that if we are small, we have to find niche areas. And the type of analysis, so for example, if you do research in electronics and you're looking at radar data, the chance of you doing a contribution is small because everybody is doing it. But if you combine radar data with something very different like text from newspapers, then you have more chance to do something new because no one would ever think about combining these two sources of data. So even for researchers, finding research projects that use multiple sources of data, and some of these sources are not naturally, we don't think of them the same. It's always a good thing to do because you can find something interesting. And as I said before, that is something that will be interesting for industry because in the end, we are looking at research that could be applied to industry to solve industry problems, which is the topic of today's talk. So what happens? We gave two examples. One example, we're getting ESG, carbon, that sort of things. Another example, we're looking at business documents. And what this is telling us is you can't really do processing and get your answer straight away. You need to build something very important called a data pipeline. So data pipeline means you need some software to gather the data, and that in itself is a very hard job. And it needs specialists to do that, getting the data from different sources, especially if you're looking at IoT data, it's very big, it's not easy to capture and that sort of things. Then you need to store it and process it. Then you need to have the software more from databases and cloud computing. Then you need to create the models to do whatever job you want to do. And this is more, let's say, from the machine learning or any other type of AI that we introduced at the beginning. Then you need something for the user, because the user, doesn't understand machine learning. They understand graphs, they understand reports. So you need to do something that tells the user exactly what is happening. And then in some cases, you're doing this because you want to comply with some regulations. So you need also something that will tell you whether you are compliant or not. So this analysis pipeline means that the problem now is not, as I said before, most people think of AI, oh, it's just this part. But in the end, you need to think about the whole thing, the whole pipeline. And data pipeline is a very important term that I use a lot in my research because it shows the different stages. So let me now summarize the problems when you do AI in industry. So there are 3 problems. The first problem is you have a pipeline. Pipeline requires multiple technologies. These technologies are very different. So the system is complex. Designing, there's too many components. How do you do that? Now, each one of these components can be, for example, oh, I need a database to store the data, but what database should I use? In the old days, all databases were SQL, but now we have no SQL, we have so many different options. Which one should I use? Oh, I'm storing on the cloud. Should I use Azure? Should I use Google? Should I use Amazon? And then when it comes to machine learning, which library should I use? When I come to visualization, which visualization software should I use? So when you look at the whole system, you need to be expert in so many things before you can produce a solution. And that's very hard for anybody, including myself, to know everything. The second problem, remember we said you need different people. How do you make these people work? Because when you write software, if it's only you doing the software, it's easy. I just sit down and I write the whole software. If it's multiple people, he's building one bit, you're building one bit, he's building another bit. How do we work? How can we synchronize ourselves? So when it's only one person building the software is impossible to maintain, it's very expensive, and if that person goes, no one can use it. And also, remember what I said, you need experts who are not computing people. You need domain experts. You need people from social science. You need people who know about culture. They need to be involved in the building of the software. How do we involve them? We need a process. We need this. So the first problem is how do we, the systems are complex. How do we architect them? The second one is more how do we make different people work together as a team to build AI software. The third one is data. So you have different data. You have text. You have IoT. You have report. How do we, when we do the analysis, we need to mix them together. What do we do? There's too many data sources, and some of the data is very qualitative. I read a report. A human person can read a report and say, okay, this report is positive or negative, but how do we turn that report into some numbers? So qualitative and quantitative data, especially when you work, for example, in the business domain, how do you do that? So what I want is focus on these 3 problems and tell you from my perspective, how do we address them? So, of course, I'm a little bit biased because my background is software engineering. So for me, you can solve these problems by looking into software engineering. What's interesting is, I was telling you before about fashion. People, in the old days, we had some disciplines that are well known, and then with the fashion, people start doing different things and so on. So software engineering is not really fashionable. People are ashamed to say I'm not a software engineer because it's not cool anymore. So I try to, of course, tell you, no, it is. And not just software engineering, any of the old disciplines. If some people, for example, here are database, I think database is very important. or some people are doing even conceptual modeling. It's hugely important. So some of the disciplines that we think are not important anymore, they are actually very important now. It's just that people don't see it. So within so what is software engineering? So that's my first question. Software engineering hasn't changed in 50 years. It's requirements, design, implementation. That's it. There's three things. And you take a book from the 50s or 60s, 70s, requirements, design, implementation. It never changed. So now, let's go back to the old cookbook and say, okay, how can this old discipline of software engineering be useful in what you were saying about creating AI systems? Creating AI system is new, it's trendy, and you're telling us this is important. And I'm going to show you why it's important. So first, what is requirements, design, and implementation? Well, requirements is understanding the business. You want to build a solution, you need to understand, analyze what you have to do. And you have functional requirements, non-functional requirements. Requirements, business analysis, same thing. The second thing is design. Design is very, very, very important because now that computing is being done by people who are not software engineering, it's, oh, I have a problem, I go and I write the code. This is wrong. You can't write the code straight away. You have to do your design. In the same way, if somebody says, build me a house, you don't take bricks and start building the house. You do the architecture. You ask the architecture to plan your house. You check the plan is good, then you build the house. Now, this is straightforward. Of course, you say. Yeah, but it's not straightforward in computing. Everybody, including people who have been in the business, they start coding straight away. They just, oh, yeah, I know what I do. They go into Java or C or Python and they start writing. And it's a mess, of course, after that. So design is important. You have to take your requirements and do a high-level solution of your software with pen and paper. Sometimes I tell my students, pen and paper. Don't code. Don't go anywhere on a computer. Just pen and paper. Think about what you want to do. Then later on, when this is okay, you go and start coding. And that saves you a lot of time. Now, do you know the golden rule of software engineering that hasn't changed and is still valid now? It's talking about bugs. If you make a bug at the implementation level, maybe it takes you a week to solve, okay? If you have a bug at the design level, that's months to take. If you have a bug at the business analysis level, the whole project can fail, okay? So this is why spending time doing the business analysis, doing the design, is actually very important, because if you don't do them properly, the whole project can fail. Whereas implementation, it's okay. If you have a bug, you can fix it and so on, okay? So, yeah, the solution is very simple. The new, maybe most important development in software engineering, besides the requirements, design, and implementation, is the emergence of a new type of methods called agile methods. So what is agile methods? It's the way people build software. In the old days, people will do business analysis, finish business analysis, say, okay, we're happy, we have the requirements, then they go to design, they do the design, we're happy, and they go and do the implementation, we're happy, and that's it. With agile methods, you do a bit of business analysis, you do a bit of design, you do a bit of implementation, and you keep going back and forth. So agile methods have made the process of building software more dynamic, more what's the word? So it's dynamic because you don't have to have all the requirements. You can start, and most companies, for example, that produce apps, you can create an app, have some functions, and then every time you do app updates, and with these app updates, your software becomes better and better. Whereas in the old days, you build whole software before you release it. Here you can release it bit by bit, and you start capturing the market, And as you capture the market, you get feedback on how to do the next bit. So it gives you that flexibility to build software. But most importantly, it enables collaboration. So agile methods helps teams to build software together, and it's also easier to involve domain experts. So the agile methods is probably the most important development that happened in the field of software engineering in recent years. And it happened because of the internet. Because in the old days, you write software on your own. Now you can, we have projects where we are in 5 different countries and we are writing software. So without the tools, the internet, to enable this collaboration, it's not possible to use agile methods. So the internet, the web has enabled these new ways of building software. So let me go back to AI. So remember, well, AI systems are complex. And since they are complex, we need to use an engineering discipline. Same way as building a bridge is complex. And you use a civil engineer. So same thing. If AI system is a complex piece of software, we use software engineering. So by definition, engineering is the discipline of dealing with complexity. So it's straightforward. But it's just the recognition that an AI solution for industry is complex. And I'm very surprised that many people come to me and say, this is a very easy problem. And you take a library, you customize, you send it, and that's it. And I don't think that's right. It's every time any piece of software, even to do a very simple task, is complex. And people have to recognize that. So on one hand, we have AI systems. On the other hand, we have experts. Some experts are good in business. Some experts, they understand the domain. Some experts, they know statistics. Some experts, they know machine learning. So what we do is we involve these experts. Okay, we need to do business analysis of this AI system. We get the domain experts, we get the business people, and so on, and we do the business analysis. We need to design the system. Okay, we look at machine learning, translation, algorithms, and so on. We look at implementation. We get different experts involved in the implementation. So now, rather than having people building things in isolation, we have now structured the way they do their work within a software engineering process. So, you guys are responsible for business analysis. You guys are responsible for the architectural design. You guys are responsible for the implementation. And then agile processes are helping these people to communicate with each other. So now I've solved the problem of, how do I get these different people to work together? Well, I have now a structure that enables me to do that. So software engineering for AI is how to support the whole process. Now, let's add some innovation, because the whole process of building an AI system is complicated. You need to understand what you need to do, the needs. You need to build the model, explore, build the solution, and visualize. So what I want to do now is say, let's look at some research areas and how could these research areas help you within the software engineering for AI. So now I moved away from just software engineering is important for AI application to research projects. So of course, these type of research projects are the sort of research projects we do. So we have research in software engineering. We look at some innovative technologies. How can we use these innovative technologies to improve the process of building an AI system? So the first innovation is cloud. Cloud computing has given us an amazing range of tools that we can achieve the building of complex systems in a way that we could not have done in the past. So let me talk about cloud architecture. So the first thing is modern cloud architecture are very complex because when the cloud started, the cloud was more or less at the bottom level. So instead of running your software on a machine, you get a virtual machine and you run your software on a virtual machine. This model is called infrastructure as a service. So you go and you use infrastructure, and then people realize, actually, if I need a database, or if I need an Apache web server, that also could be in the cloud. So we have now something called platform as a service, where you have cloud services that offer particular platforms. And then people said, oh, I can build a service on top of that. And then we get software as a service. And then people will then build front end. And then some people will look at various management services and so on. So slowly, the cloud started as some layer of virtualization on top of machines to make the use of machine more efficient, into a monster with multiple layers known as infrastructure as a service, platform as a service, software as a service. So now even people who said we are cloud experts, they are experts maybe in one layer or another. So it's actually very hard to be an expert on the whole cloud, because it has become very, very, very big and very important, and there is all this notion. But this notion of the cloud is very familiar to most of you. Is you have a independence between the service and the machine. What is a service? A service is, I need to, if you look at your mobile phone, I need to look at the weather today. You say, what's the weather in Sethi today? And you have 23 degrees. Now, is the machine that gave you this located in the US, or is it located in Algiers? Or you don't care. So the service means you call something, it gives you back the result, and you don't care where it is. And then the other machine is using other services, and that other machine is using other services, and so on. So with cloud computing, even when you take your mobile and you say, what's the weather in Setif, you could have maybe 20, 30 services called just to answer the temperature. So that makes you realize that cloud computing offers simplicity to the user, but add complexity to the software builder, because as a software builder, you have to deal with so many different things. But to the user, things look easy. So we have, how do we design AI application using cloud architectures? Well, just the notion of a service is important, because instead of building your AI application with machines saying, oh, I have a PC, and you go there and you click here and you have the result. No, just create a service, and the service will give you that AI capability that you're building. So thinking in a service way, when you're building your AI application, will give you big advantages. There is another area that is connected to business, service-oriented computing, and these areas are very close to Prof. Bugataya, because he's one of the leaders in the field. And it's called business process management, meaning that once you start thinking as a service, if you have a complex service, you can actually connect them together using a business process. So there are technologies that can help you achieve business process. So service-oriented computing, business process management are actually important part of the solution if you want to build a quality system. They are supported by various technologies. There's various protocols, which I don't want to explain, but when you use cloud architectures, you have also many vendors. So you have particularly Amazon, Google, and Microsoft. They have platforms, and these will help you to build your AI application. there are also some frameworks that specifically have been built for AI. So if you want to do some AI, we can provide you with a prepackaged solution, and you can just use it and it will do everything. Why is this important? It's because, remember when I said, if you have a problem, you go start coding in Python, maybe you can take 2 years and your solution will not be ready. But you find a framework, you can have your solution in 1 month. So it is very important, before jumping into the programming, to design your solution, because that time that you spend thinking about the design will save you 2 years, 3 years of work. And remember what I said, errors in the design will be very costly to correct. So leveraging frameworks for AI is important. And you'll be surprised to know there's lots of them. So people, of course, because AI is very fashionable, they create AI infrastructure services. And for example, Amazon has different products, Google has different products. Some vendors have proposed AI developer services to help you develop AI applications. And again, TensorFlow, C3, Jupyter. And then there are some also solutions that provide you with complete AI software services that can do AI from a box. Again, whether they are suitable or not doesn't matter. You need to look at them. In case they are, that will save you a lot of time. One particular thing we worked with is called AutoML. So AutoML is a type of tools that can automate the whole process of building a machine learning model. So basically, it will look at the data cleanup, it will do the feature selection, it will do the hyperparameter optimization, the inference, the model monitoring. So it's almost like I've seen people with no experience in machine learning, they can create a deep learning model just using AutoML. And of course, there's many different products. So all these products are AutoML tools, Data Robot, H2O, and of course, always Google, AWS, and Azure have their own products. Now, if you're in industry and you have to build an application, then obviously this is something that will be important to consider in your design. So that's the first set of solutions. Is cloud is already offering you many ways to build a design. Now, how about collaboration? Within collaboration, we have different tools. So, for example, GitHub is now a must for all the students. If you don't know how to use GitHub, you can't do anything. Coding assistants are becoming popular. So now, you probably know with ChatGPT, you have the same thing with coding. You can tell a computer, they will build code for you. You have development frameworks for people to collaborate with each other, and so on. So there's a lot of collaborative tools that help teams to work together to build AI application. And then there's one important area called DevOps. And DevOps is the teams not only write code, but they do automatic testing, automatic building. And in the old days, when you write code, maybe between the time you finish writing the code and the code is available on the web, maybe it's 2 or 3 months. Now you click and it's available straight away because of all these automated pipelines. So DevOps is very important technology that enables teams to build collaboratively code, and it's almost like a must if you do industry work. Of course, if you do AI, people have invented something called MLOps, which is a specialization of DevOps to do with building machine learning. And basically, you're building the model, you're developing it, you're testing it. What's interesting in MLOps is you have different roles. So this is the data engineer. The data engineer role is to collect the data and put it in the database. They don't understand anything else. The data scientist will build the model. They don't understand the data. And then you can have the business person that tests the model. They don't understand about anything else. So really, these types of models, they enable and help teams with different expertise to work together. And they give you a framework for collaboration. And also, they are supported by tools. So you have tools that will support ML ops, for example. Now, one last thing is when you do software engineering for AI, you have something called features. And features could be very hard to manage because you can't have one reference model for your features. What do you do? So let me give you an example. If you say sentiment is a feature of your machine learning, now sentiment can be understood by people in different ways. So if you're in finance, bad news means a news that made the stock go down. If you're in politics, bad news is, there was some kind of political event or catastrophe. So bad and good are not concepts that are easily to codify because they are relative to a context. Another example is something could be good for one country and bad for another country. So again, when you're looking at data, assuming that everybody understands the data in the same way is probably a wrong assumption. There's always interpretations by different communities and contexts. So that introduced me to my third area, which is semantic modeling and knowledge graphs. So more and more people don't store data as tables or they store them as knowledge graphs because knowledge graphs are closer to the way we think about the data compared to storing them in a traditional database, for example, or a CSV file or Excel spreadsheet, for example. And semantic modeling, knowledge graph are supported by different technologies. And there is, once you take the knowledge and you put it together, we create something called an ontology. I don't want to confuse people by going into the details, but I just need to make you aware that there are some techniques that help you model data and knowledge according to context. And these are very important to use when you're doing AI so that you can work with different data types and the integration of different data types. Now, another piece of advice is if you do a project, many people have built ontologies. Let me give you an example. If you say, I'm building a system for a hospital and I need all the disease that can happen. Now, you have an ontology that has all the disease and you can just use the ontology that has the disease. If you do finance, you have another ontology that gives you concepts from finance, if you're working with genes and so on. So with whatever project you do, don't start modeling data yourself. Always look and see if there is an ontology that already has that type of data. So now, that was just an example. So if I go back to my examples, so remember what I said, AI systems for industry are complicated because you have a pipeline, you need to get the data, you need to store it, you need to analyze it, you need to do this. Then ontologies can help you do the data integration. You can also help get the concepts from service-oriented architectures and cloud computing to do the software integration. If you're not an expert in machine learning, you can use AutoML tools to create your models. And if you have experts who don't understand computing, you can put them in an ML ops process to involve them. And this particular technology will help you collaborate together in a successful way. Yeah. How much time do I have? 5 minutes, okay. So let me just skip the So the software, the summary of the recommendation is, I've talked about 3 problems, and I've given you 3 solutions, and I just want to reinforce that. So actually, I thought I'll say these in French, so everybody understands. Le premier problème, c'est que les systèmes d'intelligence artificielle sont tellement compliqués qu'il faut utiliser des principes de conception du domaine des technologies services orientées et d'utiliser les technologies cloud. Le deuxième problème, c'est comment faire que les équipes puissent travailler ensemble. Et là, on peut utiliser des méthodes de MLOps et de DevOps. Le troisième problème, c'est comment intégrer les données ensemble. Et là, on peut utiliser des techniques de knowledge graphs pour pouvoir faire des intégrations de données ensemble. So, the conclusion is the building AI system is not just about creating the model, it's also about value creation. You're creating the software because you want to create and offer value to somebody. Who is that somebody? How do you measure this value? You need to use agile methods because agile methods enable that communication and management between different people with different expertise. You need to use information management. You need to use architectural design, process automation. So all these things are important because they are tools that will enable you to be successful when you're doing things with industry. I would like my last few minutes just to talk to you about an initiative that started last year. We call that the FinTech AI Consortium. So what we have done, we have created a structure to help us work with industry. And the reason I'm mentioning it here, because maybe this university can use something similar. It doesn't have to be in FinTech, it could be in any other domain. But we bring together some of the things that I mentioned in my talk. The first thing is, I'm an engineer, I love engineers, but engineers on their own is not enough. So it's good to have 2 faculties. So maybe, of course, we work with business faculty because this is about FinTech. So business faculty and engineering faculty work together on these business problems. In other areas could be medicine and engineering, could be anything, social science, etc. But it's good to have people who understand the domain to work closely with engineers, and that's what we have done within this structure. The second thing, it's important to have industry involved, and I saw that you have some industry sponsors for your conference, which is good. So what you need now is to get your industry sponsors to say, come with us, help our students, give us some interesting problems to work on, and that's what our industry sponsors are. You can have 2 types of sponsors. Some sponsors that offer problems, say, oh, you know, the sponsor could be, I don't know, Wilaya or Setif, we have these problems with traffic, can you help us? And some sponsors could be people with solutions, we have some technology that can help you, and that sort of things. And then the research center puts the research into different research programs. And we have use cases. So use case means that let's focus on a problem like ESG or credit or something, and then have multiple people from different research area work on the use case. And the PhD student is the glue. So the PhD student go and talk to the domain experts, they go and talk to the engineer, they go and talk to the client, and they try to build a solution that satisfies everybody. And I think that's a good model to use research students as researchers that can integrate between the needs of different entities. And this is an example. We have a complicated architecture, and you have different people that are working on it, and different sponsors, and so on. So it's important, the lesson is, it's important to think strategically about a project, saying, okay, we want to, I don't know, I'm just making it up because we were stuck in the traffic. So I said, we want to reduce the traffic problem. And maybe this project is looking at the flow, this project is gathering data, this project is looking. So you can have multiple projects, but when you attack the same challenge from different angles, and then these people start sharing information, and whatever solution they do, they put within the same framework, you have more chances to succeed. So I want to conclude my presentation by just saying that I stated at the beginning that we find this initiative very encouraging, and we would like to help as much as possible with the expertise that we have. In my case, I'm passionate about business, so any kind of business problem, I find it very interesting to work on. At the moment, we're working on fintech, ESG, e-business, but if there are other areas, why not? I'm also passionate about analytics, particularly analyzing text, analyzing data, analyzing supply chain. And finally, my core passion is software engineering, and using software engineering for AI is good because AI is so big, then almost everything that you can do in the next 10 or 20 years will be considered AI. And many people who are building AI applications are not aware of the capabilities that are being offered by new technologies. So then it's interesting to create projects that explore how these new technologies could be used to create new systems. And with that, I would like to conclude my talk. Thank you very much.